What single factor can slash system efficiency and create dangerous water hammer in a steam system? Moisture. Too much moisture destroys performance, comfort, and even equipment. Welcome to Boiler Room Detective. I'm your host, Ray Wohlfarth. Today we're breaking down one of the most overlooked safeguards in any steam system, drip legs. What they do, why they matter, or how improper sizing can turn a quiet system into a symphony of banging pipes. I've written 14 books on boilers. They're available at Amazon, Pronto Heating Supplies, HeatingHelp.com, and T.F. Campbell. Welcome back, detectives. Why moisture is the enemy. Steam rockets out of a boiler at roughly 50 miles per hour, always searching for someplace cooler where it can give up its latent heat and collapse back to water. As that steam moves through the system, some of it inevitably condenses. That condensate has to be removed immediately for several reasons. Number one, moisture accelerates condensation. It's an avalanche effect. The more condensate in the pipe, the faster the steam collapses into water. Number two, moisture overwhelms steam traps and causes system stall. Too much condensate backs up the flow, reduces heating capacity, and leads to comfort complaints. Number three, moisture creates dangerous water hammer. Steam moving at high speed can pick up pooled water and slam it into fittings or valves like a battering ram. That's how pipes crack, valves fail, and the system owners panic. Number four, moisture creates corrosion. The water inside the pipes starts to rust, resulting in thinner pipes and more rust scale breaking free to plug strainers, traps, and valves. To keep horizontal pipes dry, we use a drip leg, vertical pipe extensions that collect condensate before it can cause trouble. Think of a drip leg as a gravity-powered trapdoor hanging beneath the steam header. As steam flows forward, condensate falls straight into the drip leg instead of riding along the pipe and causing mayhem. Drip legs are typically placed at low points, every 100 to 300 feet along a header, at the end of the steam mains, and before risers or elevation changes. Without drip legs, water accumulates, leading to wet steam, corrosion, efficiency losses, and eventually water hammer. When a system starts from cold, condensation skyrockets. Cold pipes can generate more condensate in 5 minutes than they will the rest of the hour. Properly sized drip handles this surge and keeps the header dry during the most vulnerable part of the operation. Near the bottom of the drip leg, we install a steam trap, often a 3/4-inch trap, which automatically discharges condensate while keeping steam where it belongs. But that brings up an important question. Why is a drip leg so much larger than the trap? Many people assume the drip leg should be the same size as the trap. Not so. For headers 4 inches and smaller, the drip leg matches the header size. For headers larger than 4 inch, the drip leg is half the diameter, but at least 4 inches minimum. The trap connection should be 28 inches or more below the header. The 28-inch 1 psi rule. A 28-inch column of water creates roughly 1 psi of static head. During startup, steam system pressure may be close to zero while condensate production is at its highest. With little or no steam pressure available to push the water through the trap, the static head in the tall drip leg provides the force needed to move condensate through the trap reliably. No static head equals stalled trap equals backed up water equals water hammer. More reasons why the drip leg must be larger. Storage capacity. The drip leg must hold a large volume of condensate during surges. A small diameter riser would flood instantly. Venturi effect. If the drip leg were only 3/4 inches, the same size as the trap inlet, the high velocity steam in the header could create a Venturi effect and literally pull the water out of the drip leg. Debris protection. Rust, scale, and dirt settle into the bottom of the drip leg instead of plugging the traps or valves. In short, drip legs keep systems safe, efficient, and quiet. Correctly sized, they prevent water hammer, reduce wear, eliminate wet steam, and allow the steam trap to operate as designed, even during demanding startup conditions. If you have questions or steam stories to share, drop them in the comments and hit the subscribe button for Boiler Room Detective tips.